So this is going to be the session where there's some testimonials, maybe some jokes and funny stories. Although I doubt it, because Alex was a really good guy, so there probably aren't that many. You can't hear me? Do I have to go right up next to it? Yes. That really is bad. At any rate, this is the testimonial section, or the stories. Maybe some funny stories, we don't know. But at any rate, we have a list of people who want to actually say something, and the schedule is sort of there, and I'm just going to do what I want to do. So if you think you're going to talk now, maybe not. You're going to get called upon. And so we're going to actually start with Sam Olson, who said you would start first. So what? Well, Sam's coming up against some shows, but I don't know any, so are any good ones?
So we'll leave it here until Jim's up.
And also, if anybody who is going to speak needs to use their computer, there's an HDMI, so you can bring up your computer, and I know that at least one person will. So.
Tell me if I'm heard. Am I heard?
Yes.
Okay. Well, I wanted to start by talking a bit about Alex. And as you may or may not know, the laboratory has, since its very beginning, tried to have to improve in the talk between theorists and experimentalists. And on the whole, we've been quite fortunate in that. Sometimes it had to be encouraged, but with Alex, it was obviously there in his makeup from the beginning. If I had to characterize Alex's character, personality, I would say number one, he knows a lot. Number two, he's very easy to talk to. Number three, he's incredibly organized. And number four, in terms of physics and such, he's very productive. He had 700 papers or so in referee journals. He had 129 visitor letters, which for us is an amazing statistic. And more than that, he's done something else that I think is fantastically useful. And it has to do with people you collaborate with. Now, I happen to have 25 joint papers with Alex, and I thought that was quite a fantastically good number. But then I ran across something Alex had prepared. Here is a picture. You can't see much of it, but it's a list of people and the number of papers which they collaborate with Alex. If you look at this, it's quite dense. There's a lot there, but it goes on for 9 more pages. So what you find for that is, I thought I was doing quite well with 25 joint papers, but there are 36 other people who had more. Some had well over 100. It's a kind of an amazing statistic. And what I think it says about Alex is that number one, he has a huge influence in the physics that comes out of the cyclotron laboratory, out of the NSCL, and now will be FRIB. So I think that's a thing for which you can thank Alex, which he can be proud of. I hope you're proud of it. And then secondly, I just want to say a few words about something that will establish a record in the list of collaborative papers that have existed in your database, Alex. And that has to do with something that two of us when we were young researchers, that's myself and Peter Paul, when we were at Stanford in 1964, we decided that we were going to try to do experiments that let us know what was the so-called isospin mixing in the nucleus beryllium A. And so we did a bunch of experiments, and they turned out beautifully. And we analyzed the data, and we gave talks at APS meetings, and then we got jobs. We went away, and that data sat there. And it sat there for 5 years, and then it sat there for 10 years, and then 15 years, 20 years, 30 years, 40 years. Then in 2017, when I retired for the second time, I decided, well, we should look at this data. It's beautiful data, and somebody paid for us to take it. And we have an obligation in a way to publish it. But it turned out that all of my collaborators were dead. There were none left. And so I talked to Alex and I talked to Vladimir and Solovinsky, and they gave me advice. And we, in the end, submitted a paper to Physical Review C, which accepted it with almost no changes. And so that was an amazing thing. And here's where it comes in. I want to ask Alex if there's any other paper in your database in which 55 years went by before the collection of data and the publication of the result. I kind of doubt it, but I'd be interested to know. Is anybody even close? 55 years, yeah, from 1964 to 2019. So anyway, that's all I want to say. And, enjoy the rest of your meal and the rest of the talk.
So, John, you have something to work on. Yeah, because you had 5 years on that paper that you were thinking that you had 50 more years to go. All right, I forgot to mention that actually, since we're late, we're actually going to be on a very strict time, and I'm going to be a very strict chairman, and I'm going to cut you off if you go over time. So at that, I want to bring up Olaf Scholten, who should be ready, but I think you have your computer, right? Go get it. That's right.
I was told I was a guinea pig, that's fine with me.
That's you. Yeah, you're the test partner.
Yes. I hope so, I'm not sure.
Well, that's a good question. Are there?
Never mind. I'll manage. So, Alex, let me get my notes for my speaker. So, first of all, I'm happy to be here, invited to come to this presentation, to this meeting. It's 75 years, it's a long time. And it reminded me of the old days at the lab. That was the days when Sherry Conroy was the secretary in 1980 to 85, that's the time I was here, deciding how the things were going to be at the theory group. And I remember it was a very active group with, at that time, young guys as Hiroshi Toki, you, Horst Tucker, who was also young at the time, and myself. And we had long discussions, and it was really a nice and active group. I think in today's presentations there were lots of discussion about your inventivity in bringing new things to the shell model, which I will not go over anymore. I think it's impressive to see how much you have contributed to this field, and it really shows your inventivity in this respect. But I would like to, in this, use this occasion to address some other properties or qualities of you. I guess we all know you as a person who is relatively quiet, reserved, staying silent in a corner, observing what is going on, and then making some statements that are really profound, and also usually forming an opinion which is well-based and well thought through, which is sketching your qualities. In addition to doing physics, I understand you also have other qualities. Visiting your house, I was always impressed with your tomatoes and basil growth, which really worked well. We saw that you have a passion for piano music. That is, I mean, that's really, it's good to be able to play it that well. In addition, and that is what I learned at a recent visit, you have also a passion for esoteric formulas, and I guess you showed me this big 7 centimeters thick encyclopedia of mathematics, in which the most awful formulas are given, but it's fun to read it through and be impressed with what human mind can come up with. One particular ability you have is being able to combine different things. So one thing which you particularly impressed me with is how you can combine your passion for these awful formulas and music. So, one thing which you showed me was this 3D and what is 3n plus 1 problem, which is one way to make a series. I certainly don't want to discuss formulas during dinner, but no matter how it is, it's a way to generate a numeric series. And what Alex said is put this to music. So it's a fun way of doing things, but it also shows that by being inventive like this, you can combine different passions, music and formulas, and in doing so, you can create some really particular music things. So now I want to show, it's a small renderation of what you composed, but slightly modified, and I don't know if it works, but I want to, it's always a nice experience, and then you can, the whole audience then knows how inventive this is and how modern the music is. So this is a renderation of, you probably recognize it. Oh, yeah. So this shows that even at being a physicist, you can be at the top of modern composing and create.
Who is this by? Who is this by? John Cage or something?
This is your program. It's a Fortran program that does this. I'm also a Fortran. So I slightly modified the program to make it to give it some tune of myself, but it's the basic idea of Alex that shows it. Well, I see you can also be my mail. That's fine. Thank you for Alex for bringing this to the community and show how important it is to always stay inventive, come up with maybe sometimes weird ideas, but anything that can bloom into something beautiful. Thank you. As to memorize your compassion for music, we bought something for you which is musical glasses. We got a few of them that you can make in a group some beautiful music which is different from piano music. And you can fill the glasses and then do them like this. And there are the notes indicated on the scale.
That's the famous Benjamin Franklin.
So see if you can make this.
Now I want to do that.
So it's worked out. So next,
Jim and Fraser here.
What about the 418?
It's good.
Oh yeah, you don't have to worry about this part too long. Hey everybody.
No, I was just keeping.
Oh, okay, I got you. So, good evening. It's good to see everybody here. I just had a few remarks. Alex knows this, but for the room, he is one of the few people who could lure me back to Michigan. He's done it a couple of times, but to celebrate his contributions to science and what he's meant to the cyclotron lab and FRIB? Yeah. is really something that's worthy, and his birthday, gosh, I buried the lead, is really something worthy of celebration. I was Alex's student from 94 to 97, and I studied, transition from excited states and prestige nuclei. But it's obviously one of those things where you do an immersion class, and then 20 years later, you can't be expected to be fluent, because I promptly left research and went to work in Washington, D.C. So I worked on the Hill, and then went to the Department of Energy, and Alex was fantastically supportive of that. I think we knew early on in the research that I had a broad range of interests that he fully supported. I think I worked at Black Child and Family Institute for a while, was interested in some of the different organizations on MSU's campus, but Alex was the perfect advisor for making sure that I had the freedom to balance my life as a graduate student, to do those things as well as doing the research and running batch jobs. And I just really appreciate everything he's done. And as I've grown older, I've realized that, it's really rare to find a mentor and advisor who will see you as an individual and see what you need to be excited about what you do, what it means to allow you to explore and to learn in various facets of life. Alex is not only, world-renowned in his field, but maintains such a sense of curiosity and openness to new things. And I think I've carried all of that with me in my time there. So what I'm hoping that you see when you see me is that not only has he contributed so much to nuclear physics and to science, nuclear theory, but also to the field of scientists throughout the world that are in every kind of echelon of society and doing things in government, doing things in industry, as well as things in academia. So yeah, I'm just really grateful to be able to be here to honor him. And I carried so many of the lessons that you taught me as my advisor. So, thank you.
So next, Angela.
Thank you. Thank you. I'm also very happy to be here. I don't come back to Michigan myself much either, but great reason to be here. I first came here in 2005, met Alex and worked with Vladimir as well as a summer REU, and that was one of the experiences that led to me coming to grad school here and working with Alex. I found out about this event a couple months ago, and I decided I would go and try to read all of Alex's papers. I'll set the record straight. It's more than 700, Sam. It's quite a bit more. But I started, and I was portioning it out by day, and I said, I don't think I can make this in time. Okay, I'll do 1 today, I'll do 2 tomorrow, I'll do 4 the next day, and still it takes like a month to do it. It's just so many. One thing I really did learn from Alex is understanding what you know and don't know, figuring out how to present things in an accurate way. So just to give you an idea of what you shouldn't do, number of publications I think is log 10. It's right around 3, just over 3. And I think same log 10, I'm about half the number of publications you've had. So it's very similar. Same order of magnitude when you do it log 10. I enjoyed my time here very much. I learned a lot. I think one of the things I really appreciated working with Alex was, you mentioned it, but the curiosity just knowing always what's going on in the field, figuring out how you can explore those topics, what you can do with the tools that you have to explore that. And I think one thing that's often not appreciated enough is both understanding how theory can serve experimentalists. I think that's often how it's posed, but it's also understanding what experiments can do to help theory. It works in both ways, and pushing people in the right direction. I know after I left here, I went abroad. I did a postdoc for a couple years in France, and they felt they had a shell model expert. They no longer had to ask Alex questions. They could come and ask me. Gave a few shell model lecture series and spread the word of Oxbatch and New Shell, and try to collaborate with experimentalists and keep that type of framework moving forward while I was in this career for a few more years. But I think Alex will always have that appreciation from the experimentalist side. I think, Sam, you mentioned the list of collaborators, and there are a lot of experimentalists on that list that are beating you. A number of people that have had 40, 50 experiment papers with Alex. So he's really aware of what's going on and how theory can help support. And I think, the curiosity of always looking for new things and being engaged with what's going on in the field, excuse me. Playing the piano as well. I remember one of the last times I visited before I left, you had an upright bass. I don't know if you still have it. Still have it, but
I still can't play.
You say that. You say you can't play, but I remember you were just you were playing around with it because it was a new toy and it was something you could learn how to do. And I was there and you said, go ahead, try it. I said, I don't even know how to start. Now I'm a theorist for a reason. I don't even want to touch it. It was like, no, you have to try it. Just pick at it and learn. So I think that type of mindset is very good for just getting along in this field, getting along in life, always being open to new things. And I've definitely appreciated that and taken that with me in the route that I've pursued. So I appreciated the 5 years, and I still am learning lessons, and I'm happy to be back and celebrate your career, and appreciate it. Thanks, everyone.
So now it's my turn. I've added myself to the schedule. They didn't invite me to talk, but I'm going to do it anyway. So I first met Alex, I think, 39 or 40 years ago. I'm not exactly sure. I was thinking about it. It's either 1983 or 1984. I was actually his first, I think, PhD student, but I didn't start with him. In fact, actually, I started with Jerry Nolan as an experimentalist, and I was supposed to do an almost impossible experiment. I was supposed to measure the branching ratio of the super-allowed beta decay in carbon-10. And then Jerry Nolan said, actually, something really cool to do with this is go talk to Alex, and you can do some theory on this. Okay, and you could actually have some impact on the theory corrections to the thing. So I went up and talked to Alex, and Alex is actually really good. He took me under his wing, started teaching me all this nuclear physics and shell model and stuff like this. And then after about a year, I kind of decided that I was just going to be a theorist and not an experimentalist. And there were kind of two reasons for this. One was because let's see, one was because I actually had something in common with Wolfgang Pauli. Things broke when I went into the laboratory. And the other was, I forgot what the other one was, but it doesn't matter. I just decided that I was going to just do theory, and then Alex took me under his wing, and then we started doing programming and doing various things. And it was actually just a great experience, and went on to actually get the PhD there. And then he also was really instrumental in the way I kind of developed as a physicist and a theorist. In fact, there was some question as to whether or not I would actually do that, and he actually was very encouraging. And he also, the other thing that he did when I was writing my thesis is that he corrected the public education problem of the state of New Jersey, was where they didn't teach you how to write. So I sent him this stuff, and he just ripped it up, tore it up. But I was a quick learner, and actually by the second edition it was actually much better, and now actually I can really write. But yeah, he actually was the one that actually sort of worked on that. So then went off to basically do some, I'm losing my train of thought because I'm a little kind of emotional here about this, but oh yeah, so one of the things that happens in your life is that the roles reverse. So after leaving, I needed Alex to write me letters of recommendation to get jobs. So I finally got a pretty good job, and I was some middle manager at Lawrence Livermore. And then the next thing I know is I'm getting requests to write letters for him for awards and things like that, which I'm going, really? I have to write a letter for my thesis advisor? And this actually got me looking at his career and looking at everything he had done, and like, many of you have actually pointed out, it's actually really an accomplished career. At the time in which I started writing some of these letters, he had 720 publications, an H-index of over 80, and something that I discovered, there were two researchers who did a study trying to discover the impact of researchers and how they work. So their impact in their field, through all of science. And what they looked at was citations, number of authors on the publication, and the impact of the factor of the journal. And then they ranked the top 120,000 researchers of all time, and every field from archaeology to zoology. Alex came out at the 5,942nd most influential researcher of all time. Okay. Which is really remarkable. Now you can quibble about their methodology because they probably favored theorists and whatnot, but a little bit. But you know,
willing to share where you came out?
Factor of 15 higher. I did get in the top 100,000, believe it or not. But that was actually it's an astonishing thing, and that we should all, it's something that many young people should aspire to do, and it kind of, the one sentiment, as I've been trying to memorize this because it's one of my favorite quotes of all time from a movie, but the sentiment could be captured in a quote from, of all things, a movie. And you should not let this go to your head, because it's about the only time in your life that you have ever been compared to Clark Gable. Robert Ryan, in the movie The Tall Man, Robert Ryan says to Clark Gable's character, "There goes the only man I've ever respected. He is everything a boy wants to be when he grows up, and everything he wishes he had been when he's an old man." And considering your career, I think that we all could have want to have aspired to be as successful as that, and you were an inspiration. So I want to thank you for everything you've ever done for me, and best of luck. A picture taken with all the students, now or later?
Just a second later.
Just a second later?
At the end of my talk.
Oh, okay. That's fine. I thought it was now.
No,
So,
who is next?
yeah, Dean has got some things from other people, that messages that came in, and then we'll go for open mic.
So there were a few people who wanted to be here but were not able to, so I will read some messages that were sent to me. From Bertram Blank, he writes, "Dear Alex, my best wishes for your 75th birthday. I have the impression you are still in excellent shape. It is really a pity that I could not come for this celebration. Your collaboration with us here in Bordeaux started already before my arrival in Bordeaux, at the beginning of the 1990s, when you came for a visit invited by the late Francois Coubert. Ever since then, we have collaborated on many different topics: beta decay studies, 1 and 2 proton radioactivity, isospin mixing, and more. I always appreciated your availability and your quick replies, also your patience with me as an experimentalist. I'm sure we will continue our successful collaboration still for a number of years. All the best, Bertrand. And there's a message from Musin Harakin, and he writes, "Dear Alex, I'm sorry I could not attend the symposium, The Past, Present, and Future of Nuclear Structure Theory in the FRIB Era, because of another commitment in this week. Hence, I could not say a few words personally to you, but will use this opportunity the organizers gave to me to write a few words. First of all, I would like to wish you a happy 75th birthday, and many happy, healthy, and productive ones to come. We met 50 years ago. Both of us were PhD students with the nuclear physics group at SUNY at Stony Brook. We had different PhD advisors. Yours was David Falsam, and mine was Peter Paul. However, the contacts between the PhD students was close, and we learned from each other and what we were doing and how our research was progressing. Our PhD research was experimental, but combined with theoretical work to explain the experimental results. After graduation, our paths in research took different directions. You chose to continue in theory, while I decided to continue in experimental research. I should say you made a really impressive career, and your work has been an inspiration to many experimentalists and theorists. You have been very active up to now, and I'm sure you will be active in the coming years producing excellent results. I hope that we will have the chance to meet in the near future. With my best wishes, Musin." And I have a message from Kenji Ogawa. He writes, "Happy 75th birthday, Alex. It is remarkable to think that nearly half a century has passed since our initial meeting and working together. During that time, during that era, our computing capabilities were quite basic. For instance, it took several seconds to get the eigenvalues of a 10 by 10 matrix. It was, in a sense, the Stone Age of the nuclear shell model, yet we enjoyed very much the research in nuclear physics with such poor weapons. From those early days to the era of the supercomputer, you have emerged as a front-runner in the field of nuclear physics, producing a wealth of pioneering contributions. Congratulations on your extraordinary achievements. Once again, Alex, on this momentous occasion, I extend my warmest birthday wishes to you. Shizuko and I eagerly look forward to the possibility of reuniting with you and Mary in the not-too-distant future in Japan. Warm regards, Kengo." So I would like to also add my thanks to Alex for being a true role model for all the theorists at FRIB. He is about the kindest, gentlest, warmest, humblest person I've met, but extraordinary in what he does, and we owe a lot to him. Thank you.
So, Eric, may I go now?
No. It's also open mic.
No, but
You have to go last. So, you might be next, I don't know. So this is the open mic section in which anybody else who would like to say something may. I'm the chair.
Age of power.
Greetings, everyone. My name is Greg, and Alex and I have been very close friends for nearly 40 years, and our families have been very close for all that time. And Alex and I have had lots of fun together. We've enjoyed many events of family and friends over the decades, and it's been good times. What you might not know is that Alex and I are both part of a monthly Bridge group. It's a card system that challenges even particle physicists. And we're also part of the monthly philosophers group, a small group of us who have done a very poor job of solving the world's problems, but we've had lots of good wine and good fun. And Alex and I enjoy many things together. Fine wine is one, good food, of course, music. You're all very aware, of course, that Alex's accomplishments and achievements are things to be highly appreciated and highly esteemed. What I can say is, so is his friendship.
Does anybody else wish to come forward and say anything? Oh, looks like somebody.
Okay, I think on the list of Alex collaborator, I'm somewhere at the bottom of the page number 9. And the number of joint papers is probably within a single digit, yeah. But I still think that these papers, which you did over this many years, you can go read them again and you will find something which is really valid today, and it's inspiring us, like the study of 1800. So, no surprise, I got something which was really attached to the date where we were working together, and we had a paper, 1994, in 100 was identified. So you have the same number of protons and neutrons, there are two atoms, and there are different. And there are really 1994, yeah. Okay, now. Okay, okay. Perfect. Thank you. That's
Anybody else who would like to come forward with some juicy stories? I'm sure there aren't any, but if not, I guess we have to let the birthday boy talk. Do his thing.
Well, this has been quite a humbling experience. I never dreamed that this would be. But, you know, life will go on after this, I guess. So what's this thing on the screen? Is that on your screen too? It's not. Yeah, just on my screen. So I've had friends that tell me at this stage, just do it quick, get it over with. Keep it simple. I'm trying to do all those things at this point in time. So, odds and ends. And when you get to this age, you think to yourself, how did I get here? And it's actually, the question is, how did we get here? Because you and I are in the same place. I have this big red thing right in the middle of my screen, and I guess I'll try to ignore it. I'm going to start, and this will be short, but you wouldn't know it from this. I'm going to start in high school. High school. One of the ways we got information in a small town in Ohio was from the magazine Scientific American. Anybody else know that? Now, at the time, it was really the only way you could get current research without having some other sort of connection. And it's still very good. And so, for example, this magazine from 1964, I was in high school, maybe a sophomore or something. I'm sure I looked at this magazine, it was on mathematics. And you see the window. It was a great magazine. And the way, you know, I say this because how did I get here? I was reading things like this in high school. That's what I want to say. Now, it turns out this is a 300-page magazine. And it happens that on some page of this magazine, which I may or may not have seen at that age, there was an advertisement for the supercomputer of the time at Michigan State University, which they claimed ran the cyclotron calculations 30 times faster than something. Okay? I may have seen that, but I'm just saying there's a possible connection between when I was in high school, you know, and the cyclotron here, because this is when they were building the cyclotron. And of course, at this point in time, they were trying to do calculations for the beam. You get the beam around the magnetic field. Now, one of the things in that magazine you realize right away, it is 99% by white males for white males. So one of the things that, how we got here, is that our lab has always been emphasized the diversity issue. That is, there is more than 99%. There's a lot more out there. And it turns out that we've been kind of lucky in nuclear physics, because in women Nobel Prizes in physics, there's been only 4, and they're right there on the screen. And up until recently, there was only 1 every 50 years. But the first 2 were in nuclear physics. And there is Maria Gilbert-Meyer, and there's her first day issue stamp from St. Paul, which I happen to find someplace. So it's an issue which we have to face. Women and minorities in physics, because as I say, back in those days, it was just us. Small history. So how did I get from high school to here? Well, I went to Stony Brook, and the first thing we did as an experimentalist is that we were sent to the shop, and we had to make a nut and bolt. Unbelievable, isn't it? Because we couldn't do experiments unless we knew how to make a nut and bolt, and I still know that. And then when I went to Japan, there was this thing we hung on the door. Taka, where are you? I don't see you. Now, let's see. The red is for in and black is for out. Is that the way it was? The opposite. The red is for you're in your office, and black is for out of your office. You don't remember? Oh, anyway, this is your thing on the door, and you hung this thing on your door so people would know if you're in or not. Okay. What? Red is in, right?
Yeah.
Oh, no. What?
Red is out.
Red is out? And so Akito tried to write my name in some sort of Japanese style. You can just barely see it on there, which I honestly don't remember what it said. Maybe Tom can read it or not. It's really hard to read, so don't read it. Okay? But then, getting through all that, we end up in the cyclotron. and so I told you about that. I told you about that supercomputer at Michigan State in the mid-'60s. Well, the faculty came in the mid-'60s. And that supercomputer was not for the faculty, it wasn't for the theorists. It was for the people that were designing the beam. This was for the accelerator people. This was the K-50 at the time. You to get the beam of nuclei out, and so they needed a machine to track the path and through the field. And so these are the people, actually this first group up here, this is a little younger than what I knew them, but it was pretty much the group that I knew when I came in '75. And that picture of me, I think, hanging in the wall for like 20 years. So I got used to just having pictures up for many, many years. I think they finally took a new picture of me a few months ago. So, Sam Austin is here, by the way, right there, and Walter Benson is here. Okay? So, it's amazing. The two people from that picture are here. I think this is a postcard that you could buy in the shop of the control room of the cyclotron. And this is where I started. I am sure I sat in that chair many times. Not a lot, but many times. And one of my memories is that an experiment, one night I was on shift somehow, I don't know the experiment, and I was there at that control panel by myself in the middle of the night, and then you have to change the ion source, which means you have to go back and turn off the magnet, and then you have to go back and climb up on top of the cyclotron, pull out the ion source of the pig, and put a new one in, put it back in, turn on the magnet, and hope that the beam comes back on target. As far as I know, I was the only person in the lab that night. They don't do that anymore. They don't allow you to do that. But you'll notice a phone, I think that's a phone, on the left-hand side, and there's a little phone number there. In case the beam does not come back on target, you call Henry Bosser, and he will either tell you in words how to get it back, maybe come in and get it to work again. I started in the, people have alluded to this, about dark ages or caveman ages of computing, when programs are written on cards like this. I spent like three or four years, I mean up to like 76, doing this kind of computing. And there you see on the bottom left, you'll see a big room, it's not our room, of just a whole bunch of boxes of cards. Each box held about 2,000 cards. My typical program is 30,000 lines, so there's many boxes, okay? And so you can imagine how long it took to do something. You would put those cards in the reader, come back in maybe 5 or 10 minutes, and there would be a mistake. So you'd have to copy one of those cards and make a new one to correct the mistake. There was a machine that did that. But eventually it worked. Now, in the old days, there wasn't much there. I was in the basement. But all the activity was in the basement. My room was in the basement. The seminar room was in the basement. Probably many of you don't even know where the basement is. You've never been down there, but it's down there. And that was the snack room and all that stuff. Anyway, there were lots of punch cards. Anyway, things have evolved. And now, here is me on the beach, working on a program. What? So moving on, this is the conference that Alfredo alluded to in our meeting. He called it 1975, it's actually 1976. This was a very unique school, 1976, Verena Summer School. It really got me into Italy, by the way. We love Verena, we love all the conferences that we have in Italy. But you'll see in the bottom, first of all, you'll see in the top, you'll see Alfredo in the circle there. You'll see Aldo Cavallo, which many of you know. And you'll see Robert. Where is he here now? Yeah, is that you? Did I get you? Yeah. And there were lectures by all those foreign models that had just won the Nobel Prize in 1975. So there were lectures by Boren Modelson, all those people whose name is covered up by this red thing on my screen. But you see Arthur Kerman and Ricardo Broglia, Egal Talmy, who was a great mentor in nuclear physics. You're familiar. Arthur Kerman. And I remember one of the things you do, one of the things that pays to do as a student is to ask lots of questions, even though you may not know what you're asking. Just ask lots of questions. And I got into an argument with Egal about something. I remember we argued for a while. And we eventually just gave up. But afterwards, I realized he was right. There's about some sort of isospin mix in some places. If you go onto my webpage, you can actually, there's a screen that shows you this was back in the days where they took very high resolution pictures of everybody. So you can zoom in on anybody you like to see, Boren Modelson and so forth. Hobson Weldenthal, who was my advisor back then, is in that picture. And this meeting was kind of a transition between the collective models and all that and the kind of shell model which we were starting to do at the time. In fact, Hobson gave a large series of lectures at that summer school. So you see my webpage, you can go see everybody else that you know in that picture. Odds and ends, how did we get here? Just a couple of odds. Papers and refereeing. John, you're over there still, right? Oh. I've invented a new thing called a B index. Which is here. You still can't see it. But the B index is on my website, so you can go, you can zoom in and get your name and everything. But the B index is how many papers that you have written with me. I'm looking around to see it. And there's a little bit of color coding. There's a red, which is over 30 papers, and there's about 30 people, and they include Alexander Gade. I think that's the top. So where are you at? You have the highest P index.
It's like 132.
Huh? Something like that. Yeah?
It looks like it's 132.
Right. That's the highest. In red. So this should be right up there, right? You got your H index, you got your okay. It's on my website. Have a look. See what your B index is. Oh, just a couple of curious little things. In 1998, I wrote a paper about some sort of thing called skirmix. And when I went to give a lecture in Tokyo, Taka asked me, why is it called X? Didn't you? Do you remember?
Yes.
And I said, well, you know, X is spatial. Generation X and all that. But then right after that, somebody stole it from me. Elon Musk made a website called X.com. If I'd only thought of that, look where we'd be. Anyway, he did X.com and he turned it into PayPal, and then he gave up PayPal, And then he bought Twitter, and then he turned Twitter into X.com. What can you do? You lose. Okay, that's kind of odd. In 2000, I submitted a paper at the end of May on something about Lib 208. I submitted a paper at the end of June on something about Lib 208, completely different topics, to a journal called Physical Review Letters. And I had pretty good luck that year. The referees were kind, and I could see that they might be accepted at some point. So at that stage, my goal was to get them published in the same week. And so I sort of delayed everything, didn't respond and everything. And it worked. The same issue, and 2 papers by me on Lib 208, but completely different subjects. It's just a curiosity. I'm not bragging about anything, but it's just something that I worked on at the time. Oh, here's one with 40 authors. And no last name is longer than mine. And the other, now you may ask the question, how many of these people do I know? Okay, of course, a lot. I know most of you. I would say I don't know any of these people. It's an embarrassment, really, because maybe I should. It's a whole, Chinese group. But you see, they all have 2 or 3 or 4 letters.
It's a brief collaboration.
Yeah, brief. Well, so now we're at the end. So this is short. Odds and ends, how did we get here? So first of all, let me just emphasize again, how did we get here? The leadership in the lab. I don't just mean the directors, which I've served under all of them, but the leadership, meaning the experimentalists and the group leaders and everything like that. The only thing we realized is that to make progress, we had to go up in whatever way we could dream up. If you don't go up, if you go down, you're out, obviously. If you just stay flat, you're out, obviously. But you have to go up. You've got to be bigger. You've got to be more inventive. You've got to do something new. And so I've been fortunate to have been able to work with all these faculty that did that. They did something new all the way up till now. The directors also allowed me to more or less do what I wanted to do. And somehow these 2 things work together. So that's how we got here. People and things. On my website, I have a whole list of special people, what I call mentors and colleagues. I'll let you go look on my website. There's a little link up there. It's none of you, but it's people that have come before. It's what they say in Africa, what they say in Botswana is at least these people are late, but they have been influential. Oh, well, how did I get here? You asked, how did I get here? Thanks to my wife, children, and friends, Mary, right there. Where's Mark? Mark's over there. And Elizabeth. They've had to live through all these things. Most of these papers, they've had to be with me wherever I travel, whatever I do. And many friends. I'm not going to try to name everyone, but they're at this table, they're at this table, they're at all over these friends. Thanks to the organizers. Okay? This is the organizers, in particular Dean Lee, who was huge amount of work to get all the details down. Alexander Gade, who has done a lot of work. I thank John Crucho for the great piano and allowing me to show off a little bit. Is she still here? Let's see, where are we? Thanks to the organizers, thanks to my students. And I think this is it. So this is the time for my students to come forward and to stand up here, take a picture. And here they come. So, most of them are here. Rod Roddy was from Iraq. He was an early student. Eric Armin, you know very well. And Zal, I have no idea where he is. And Jamie Frazier, and Angelo Signoracci. Does somebody have a camera? Aaron McGilligan and Jordan Purcell. Where is he? So, somebody has a camera. We're going to go over here and take a picture. Oh, sure. Got it? Yeah.
Same here.
That's it. So thank you for coming, everybody. You've come from a long way away. It's been wonderful.
That's why they brought the cake. So you